Hello everyone, welcome to AEROHUB. Today I'll be talking about aircraft structures, the different parts of fuselage, wing, empennage, and how loads are transmitted from one part to the other part. So let's get started. Aircraft structure. So here we have this five important parts of an aircraft: fuselage, wing, empennage, landing gear, and power plant. So fuselage is the primary body of an aircraft which holds all the things together, where all the parts are connected to the fuselage. It carries the passengers and cargo. Wing is attached to the fuselage. The primary purpose of a wing is to produce lift. The power plant is used to produce thrust in order to move an aircraft forward. Empennage is the tail, which consists of vertical stabilizer and the horizontal stabilizer. It is used to control the movement of an aircraft. Landing gear, it provides support. It provides support to the aircraft during landing, takeoff, taxiing, parking, and towing. So, fuselage structure. Fuselage, as I said, fuselage is a main structure or body of an aircraft. It holds the things together. All the other major parts are attached to the fuselage. Basic fuselage types. There are three types: truss type, monocoque, and semi-monocoque. Truss type, under truss type we have Pratt truss and Warren truss. So we will understand one by one what are these different types of structures. Truss. A truss is a rigid framework made up members. It is a structure composed of slender members joined together at their end points. Most of the early aircraft used this technology, and this type of structure is still in use in many lightweight aircraft. The truss type fuselage frame is assembled with members forming a rigid frame. Example: beams, bars, etc. So the primary member of this type of structure is longeron. There are two types of truss structure. One is Pratt truss, the other one is Warren truss. Pratt truss, the primary strength member is these four longerons. The longerons here, these four longerons are the primary strength members. Longerons are connected with rigid vertical and lateral members called struts. The diagonal members are designed to carry only tension. In this type it is difficult to streamline. This is Warren truss. In this type, the longerons are connected with only diagonal members. Loads are transmitted to all the structure. All the members are capable of carrying both tension and compression. This type of structure provides more space, strength, rigidity, and better streamline. So tension is basically a pull and compression is push. Tension is the resistance to pulling apart. Compression is the resistance to crushing. Bending includes both tension and compression. So the next type is monocoque. The monocoque, it is a single shell fuselage, relies largely on the strength of the skin. Skin carries the primary stresses and keep the fuselage rigid. A monocoque construction uses formers, frame assemblies, bulkheads to give shape to the fuselage. So this is the skin. It carries the primary stresses, all the primary stresses. The formers, bulkheads, frames maintain the cross section of the fuselage. It maintains the cross section shape of the fuselage. Semi-monocoque. This is the preferred type for constructing a fuselage. In addition to frame assemblies, bulkheads and formers as used in monocoque design, the skin is reinforced by longitudinal members called longerons. So these are the longerons which run parallelly from the nose to the tail. The biggest problem involved in monocoque construction is maintaining enough strength while keeping the weight within allowable limits. In order to overcome this problem, semi-monocoque construction was developed. Longerons extended across several frame members and helped the skin support primary bending loads. The longerons, the longitudinal members, that is longerons and stringers, they carry this bending loads. They're generally made up of aluminium, and this is the wing attachment point here in the fuselage where wings are attached. This is the firewall. On single engine aircraft, the engine is usually attached to the front of the fuselage. There is a fireproof partition between the rear of the engine and the flight deck to protect pilot and passengers. So this is semi-monocoque. So now we'll understand how the loads are transmitted. So these are the typical parts of a fuselage. So skin, longeron, bulkhead and stringers. We also have frames, formers, rings. Frames, formers and rings. So the skin transmits aerodynamic forces to longerons and stringers. Longitudinal members, that is longerons and stringers, resist bending and axial loads. The formers, bulkheads, rings maintain the cross-section shape, distributes the concentrated loads. It acts with skin in resisting the circumferential loads. So what are the circumferential loads? They are the normal stress in tangential direction. So this is how loads are transmitted. Wing structure. Wing is a very important part of an aircraft. It helps in producing the lift, and hence it must be designed and built to hold its shape even under extreme stress. There are three systems that are used to determine how wings are attached to the aircraft fuselage depending upon the strength of a wing's internal structure. The strongest wing structure is full cantilever. This is a full cantilever which at one side is directly attached to the fuselage. The semi-cantilever usually has one or two supporting wires or struts attached to each wing and fuselage. The externally braced wing is typically for the biplane, which transmits the flight and landing loads through the struts to the main fuselage structure. The typical parts of an aircraft wing are spars, ribs and stringers. Wing ribs gives the shape. These wing ribs give the shape of the wing. Spars are the main members of the wing all the load carried by the wing is ultimately taken by the spars. In flight, the force of the air acts against the skin. This force is transmitted to the ribs and then to the spars. This is the fuel tank. In most of the modern aircrafts, the fuel tank is either an integral part of the wing structure or consists of containers inside the wing. Ailerons and flaps are the two control surfaces attached to the rear or trailing edge of the wing. Aileron is a primary control surface. It is present at the wing tip. So it is used for the rolling movement of an aircraft. Wing flap is used to increase the lift. While moving flaps downward, lift force can be increased. So wing flap and aileron are the two control surfaces that are attached at the rear or trailing edge of the wing. Slats on the other side, they're also known as leading edge devices. They are attached at the forward, in front, at the leading edge of the wing. They increase the lift. The frontal area, this is the slat here and this is the flap. So they can be retractable. They are used to increase the lift by increasing the surface area. So next we have empennage. Empennage includes the entire tail, consisting of fixed surfaces such as vertical stabilizer and the horizontal stabilizers. So this here is a vertical stabilizer and this is horizontal stabilizer. Vertical stabilizer has rudder and horizontal stabilizer has elevator. Rudder and elevator are the primary control surfaces. So aileron, rudder and elevators are the primary control surfaces. Rudders are used to control the movement of an aircraft. They are used to turn the nose left or right. Elevators on the other side, they are used to pitch up or pitch down an aircraft, pitch up the nose or pitch down the nose. The trim tabs are small movable portions of the trailing edge of the control surface. They reduce control pressure. And these are the parts here. We have ribs, spars, stringers, skin. All these parts, they transfer the loads and they strengthen the part. So this is all about the aircraft structure. Thank you so much.